Hey guys, welcome back to the channel. In this video, we are going to discuss Nyquist plot, and this is from subject called control system. So let's start. So Nyquist plot is done to calculate the stability of the system, and this Nyquist criteria stability can be calculated by this formula called n is equals to p minus z. Here n are the number of encirclements, p are the open loop poles of the system on the right half of the plane, and z are the closed loop poles of the system on right half of the s plane. So whenever the z will be equal to 0, the system will be stable, the closed loop system will be stable, and if the z comes to not equal to 0, then the system is said to be unstable. So basically we can say that we want z is equals to p minus n, and here this number of encirclements n is positive when the encirclement is anti-clockwise, and this n is negative when the encirclement is clockwise, and we should take the poles which are only on the right half of the s plane. That means if here we are having some pole on -1 -2 and a pole on 2, then we have to consider only this pole, not these poles, and this process is a little different from previous plots which are polar plot, and here we have to consider the poles which are only on the right half plane of the s plane. Reference point is always fixed, which is -1 plus 0j. Keep it in mind that this point is always fixed. P is open loop pole on the right half of S plane, and also Z is a closed loop. So if Z is equals to 0, the closed loop system is stable, and if this is not equal to 0, the closed loop system is unstable. See, you might ask that what is this number of encirclements? So the number of encirclements around the reference point, this reference point is always fixed. Let's say we take a point, this point, reference point, and here a circle is around this point, let's say like this, and this is in a clockwise direction. So the circle around this point is in clockwise direction. That's why we are writing n is equals to -1 because of this rule. And if it is in anti-clockwise direction, then the n value will be positive. Let's take one more case. So now you might ask that this part is going in anti-clockwise direction and this part is going in clockwise direction, so what should I write the n value? See, just take a straight line, imaginary straight line, and see that this is crossing in the anti-clockwise direction and this is crossing in clockwise direction. So n is equals to first anti-clockwise direction, that is +1, and then clockwise direction, that is -1. So n is equals to 0. That's it. Easy, right? And now let's come to poles and zeros. I think you might know about this, but even if you don't know, I'll explain it. So let's consider an open loop transfer function, that is g of s is equals to s plus 1 by s into s plus 1 into 2s plus 1. So here pole are the number which make the denominator equal to 0, and if we put s equal to 0, the denominator will get 0. So s equal to 0, and if we put s equal to -1, this part will become 0 and the overall part will become 0. So s minus 1 can be used. So also s is equals to -half is used. Then also let's take -half plus 1. Then this is -1 plus 1. It is 0. So the overall denominator will become equal to 0. So we can put -half. So these are the poles of this open loop transfer function. And 0 is the number by using which we can make the entire function equal to 0. That means if we multiply with 0, the overall equation will become 0, right? So if I put s equal to -1, it will come out to 0. So s is equals to -1 is the 0 of this open loop equation transfer function. But the twist here is that we have to consider only the poles which are on the right hand side of the s plane. So here we can see that this is on the left side, this is also on the left side. The 0 is only thing which lies between the left and right, so this can be considered. So let's see what are the procedure to draw a Nyquist plot. First step is to draw a contour. Contour is nothing but it encloses the entire right hand side of the s plane, and It tells that what poles are present on the right half of the plane. So a contour is used to know the presence of the poles on the right half of the S-plane, and it encloses the entire right half of the S-plane. So this is called the Nyquist contour. So if there is no pole on the right hand side or at 0, then first from origin it will go towards infinity, and then it will cover the entire infinity plane, and it will again come back to minus infinity, and this will again terminate to origin. So this is for first path C1, and again it is coming back here to minus infinity. This is C2, and when it goes to origin we say that this is C3, and this is the origin. So here we can say that the radius is equals to infinity. And let's say if we are having a pole at the origin, then we have to just leave this origin a bit. I'll show you. Go from origin to plus infinity, and then again from plus infinity to minus infinity, and we will go back to origin, but it will not touch the origin. It will terminate from the origin and will continue from here. It will start from here only, leaving some space, and it will go to plus infinity. Again it will go to minus infinity, and it will terminate to until this point, and we will leave the origin a bit and will continue to next path. So this is C1, this is C2 until minus infinity, and then this is C3, and this path is called C4. So this is the case when there is no pole on the either right half of the plane or on the origin, and this is the case when there is a pole on the origin. So these contour have to be drawn on the first step of drawing of our Nyquist plot, and for next step we have to substitute S is equals to j omega in the transfer function. I mean, given question they'll give transfer function only, so we have to substitute S is equals to j omega in the transfer function, and this transfer function, here the omega varies from 0 to infinity, right? The omega varies from 0 to infinity. So we will calculate the corresponding phase and magnitude values, and we will draw polar plot according to type and order, or we can also draw with using some another method, and then we will separate imaginary and the real part by rationalizing the equation. And then if, like, let's say we got this graph, this diagram, okay? So this is touching this x-axis, right? So this x-axis is real axis. So when it is touching the real axis, we have to make the imaginary part equal to 0, and then we will substitute this imaginary part into the magnitude. Then we will get this point which is intersecting the real axis. And let's say we are having some another like this, then it is touching the imaginary axis, right? Then the imaginary axis point of intersection can be calculated by putting this real part equal to 0, and this whatever value will get, this will be substituted into magnitude. This will give the real value, which is the intersection point on the imaginary axis. I'm telling you, this will be understood only if we are doing a problem. So if you are not getting it, no need to worry. I'll explain you this in next video when we will do some problem, okay? So the next step is to put S is equals to limit capital R tends to infinity R into e to power j theta. This is for C1, this is for C2, and here we can see that C2 is coming from minus infinity, plus infinity to minus infinity, but this angle is plus 90 to minus 90. So here this theta is varying from plus 90 to minus 90. In this step we will calculate the magnitude and phase, and we will again draw whatever diagram we are getting according to the magnitude and phase. So the next step, which is step 4, is to get the diagram of C3, right? We can get the diagram of C3 by seeing the mirror image of C1. It is the mirror image of C1. So let's say this is the C1. So we will get like this, we will get C3, okay? Now for C4, which is not in the case of when we got pole not equal to 0, but when we got pole equal to 0. In this case, when we got pole equal to 0, so for this C4 we are going to calculate. We have to put limit small r tends to 0, small r into e to the power j theta, and here the theta varies from minus 90 to plus 90, and we will calculate the phase and magnitude, and we will draw whatever diagram is coming out of the magnitude and phase. So in the next video we will see a problem, and based on which you will be able to understand the entire Nyquist plot. Thanks for watching this video. If you understood the concepts, then don't forget to click that like button, and also don't forget to subscribe to my channel. Thanks for watching.